Hi, welcome to this lesson on bitmap graphics for National 5 Computing Science. And this topic comes within the computer systems unit within the arrangements, in particular this part here. Describe the bitmapped method of graphics representation. Okay, so you've maybe seen this sort of image before, lots and lots of ones and zeros. And believe it or not, this is what a graphic looks like to a computer. When it is saved or transmitted or loaded, this is what the processor will actually see. When these ones and zeros are all processed, it might actually be a picture of a beautiful scene, it might be a frame of a movie, it may be a selfie. It may contain millions of different colours, or it may just be black and white. But every one of these ones and zeros gives us a little piece of information. For instance, this here could be a black pixel, or this group of ones and zeros may go together to make one pixel of a single colour, such as light blue or bright pink. I'm going to go on and tell you how this can actually be. So first of all, a bitmap graphic is made up of pixels. Now, pixel stands for picture element, and most photos in this day and age will have millions of picture elements to make up one complete image. And this is where the term megapixels comes from. Mega means millions, so every time you take a photo with a 5 megapixel camera, it means it's taken 5 million pixels to save that particular image. In this image of an eagle, we've zoomed in once to the eye and then zoomed in again in order to be able to pick out every unique pixel that has gone together to make this image. Each one of these pixels will have a binary number in order to identify that particular colour. So how can a pixel have a binary code? Well, it depends on how many bits are being used to save this particular image. You've maybe heard of 8-bit graphics. That means that every single pixel in an image uses 8 bits to save that particular pixel or to save that colour of the pixel. In 1-bit graphics, every pixel only uses 1 bit, which could either be a 1 or a 0. A 1 would represent a white pixel and a 0 would represent a black pixel. If this image here on the left was saved as ones and zeros, the code would look like this. So if an image is in black and white and it's used 1 bit per pixel, it's fairly easy to work out a code. So if we went back to our ones and zeros and tried to work out what the image was, we would draw a black pixel for every 0 and a white pixel for every 1. So what if we use 2 bits per pixel? Well, that means we're not limited to only 0 or 1 or black and white. We can actually have 0, 0, which might be black. We might have 1, 1, which is white, but we might have 0, 1, which is blue, and 1, 0, which is red. Now, by using 2 bits per pixel, it's allowed us to have 4 different colours because that's the amount of combinations we can have with 2 numbers, 1 or a 0. 0, 0, 1, 1, 1, 0, and 0, 1. So going back to the start of our lesson, we saw all the green ones and zeros. If we were to see this image, this red, blue, white and black image, the first line or the top line of this image would be represented with 0, 0, 0, 1, 1, 1, 1, 0. And this is what the rest of the image would look like represented this way. Note how the bottom line is all ones because it is all white pixels. So it's 4 1 1s. And one more example of this is if we use 3 bits. This time we would use all combinations of 3 ones and zeros. So that would give us 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. This means that we have 8 different combinations, which means we can have 8 colours. So for 3-bit graphics, we can have 8 different colours, which starts making this image look a little bit more interesting. And here's how the binary would look for this particular image. Now the number of bits that are used to save an image, such as 1 bit per pixel, 2 bits per pixels, or 3 bits per pixels like we've just seen, or even more, that's known as the bit depth. And the number of colours that can be represented using that many bits is known as the colour depth. Now you may have noticed a pattern in the numbers that we are seeing. For 1 bit colour depth, we can have 2 different colours. For 2 bits per pixel, we can have 4 colours. For 3 bits per pixel, we can have 8 colours. For those of you who have worked out the pattern, for the amount of bits that you have for the bit depth, if you do 2 to the power of that number, you will get the amount of colours that that amount of bits can represent. So for a GIF, that uses 8 bits per pixel, which means it can have 2 to the power of 8, which is 256 colours. JPEGs use 24 bits, which means they would have a colour depth of 2 to the power of 24, which is 16,777,216 colours. This is roughly the same amount of colours that our eyes can discern between, so there's not much point in using any more bits than this particular number. You should also note that using more bits per pixel in order to give you more colours will also give you a larger file size. The last thing we need to talk about in this unit is resolution. If you have recently bought a television, this is one of the main factors that you would have thought about when or before buying this. Now, if you're thinking that you want a very crystal clear image on your television, then you'd be looking for maybe Ultra HD or 4K. But what does this actually mean? Well, it means that these televisions will have a high amount of pixels within that TV screen, much more than standard definition. And because there are more pixels, it means there could be more detail in every image, which means that the quality is going to be far higher. So to summarise, resolution is the number of pixels in a fixed area of a bitmap graphic or a device like a screen. High resolution images have a large number of small pixels, and low resolution images have a small number of large pixels, which makes things look more spread out, which makes the pixels look bigger, which makes the image look more pixelated. High resolution graphics have better quality than low resolution graphics, but require more storage since there are more pixels in the image. The resolution of graphics is normally measured in DPI, or like I've said before, megapixels. DPI stands for dots per inch. The best quality of image would have a large amount of colours, which means more bits per pixel, and a large amount of pixels, which means saving all those bits for every single pixel, which would result in a large file size. And that's when we need to think a little bit about compression. But that's for another day.